Hello, everyone. Welcome to today's On the Edge with LF Edge webinar, Real World Edge Computing. We are going to give it just another minute or two before we get started so we can allow folks to sign in. So just hang tight with us for just another minute or two. All right, we're going to go ahead and kick things off. Thanks, everyone, for joining us today. We've got a really great discussion focused on the Open Horizon project. Today's title of our webinar is Real World Edge Computing, Scale, Secure, and Succeed in the Realm of Edge Computing with Open Horizon. Our speakers are Rob High. He is an IBM fellow, a VP, and a CTO of Edge Computing, retired. And we've also got Sanjeev Gupta, who is with, he's an Edge Computing lead also with IBM. They're going to be kicking off today's discussion and sharing some really great insights. Just a couple of housekeeping items as we get started here. If you have questions, please go ahead and put them in the comments section. We will address those after the initial presentation. We've left quite a bit of time for Q&A, so feel free to put those in the chat window. And the recording will be available for viewing after today's live session. So stay tuned for that. All right, without further ado, I'm going to hand it over to our speakers today.
Excellent. Thank you, Jill. Appreciate that. And thank you guys for having us here. And shout out to my friends and colleagues I see joining us. Thank you, guys. Appreciate seeing you guys again. And what we're going to do today is talk a little bit about how to make edge computing real in your production environments. Sanjeev and I have just completed writing a book, and we'll talk a little bit about that later. But most of what we're going to see is an outline of the content that we include in the book and some of the things that we'll talk about there later. But Sanjeev and I both, as well as my colleagues at IBM, literally have years collectively of experiences with, actually I say years, probably decades if you really count it all up, of experiences with edge computing and putting these together in for production purposes. But let's sort of start with the basics, because I always worry that sometimes we lose people when we drop into these topics. I assume anybody here who's involved with edge computing probably knows this, but it's always good to be on the same page. So why edge computing? Let's just talk about that for a moment. And there's really kind of four major reasons why edge computing has become so important. The first of those is latency. You know, if you think about computing being done in the cloud or an enterprise data center, and the things that you do in your factory or in your retail store or anywhere out there in the world where real business is being conducted, the latency to get back to the cloud, to process your data, and to help you make the decisions for what you do next can be quite large, literally hundreds of milliseconds of latency, which, you know, maybe is okay for web browser-based applications, although frankly, I find that a little bit annoying, but it's unacceptable for many production processes where you need to make decisions in the things that you're doing on your production line in literally, you know, 1, 2, 5, 10 milliseconds. If you're going to be processing, for example, you know, any kind of visual inspection for quality, On a production line, you may only have a couple of milliseconds to decide whether there's a quality issue or not before the machine moves on to the next part that it's producing. So latency does matter. And if you need to reduce that latency, you've got to bring the compute close to where the data is being produced. It might be the visual data, for example, on your production line, and where your decisions are being made. The second reason is, we call it security, but really I'm talking about here is data, privacy, and confidentiality. The data that you're collecting in your production environment, and that of course applies to industrial environments, but also in retail environments, agriculture, anywhere where you've got data being collected. If you're sending that data across the network back to the cloud or to your enterprise data center, you're increasing the risk that that data is going to be intercepted and exploited. And so you want to reduce that traffic. You want to remove the potential for that data to be intercepted by keeping that data local. If you're collecting visual data, which is, I'm going to come back to many times because that happens to be one of the more common examples of use cases that we see out there. If you're collecting data from a camera, you may have in mind the thing that you're focusing on, but all kinds of other data may enter into the picture as well. You may have other workers or consumers, customers walking past the visual reference, would be past the video camera frame of focus. And now suddenly their information, their personal information, their identity could be exposed. If you've got other information, if you got other things happening in your warehouse or your production environment, if you got inventory being passed around, people could use that visual data to determine what state your manufacturing processes are in and use that as a competitive advantage. So keeping that data local becomes really important, and that's why edge computing is essential in these environments. Efficiency. If you think about doing visual inspection and you're sending frames and frames of data, visual data, back to the cloud, and all you really need is that one frame where the quality issue may surface, or where the identity issue may surface, or where the inspection issue may surface. All the other data is superfluous. And so by sending that and transmitting across the network, you're consuming resources that are going to be costly and perhaps aren't even available to you. And so you want to think about how to reduce that overhead as you collect data and process it. And the last is what we call resiliency, which is really how do you keep your business running when the network fails, or where you can't get access to the cloud, or where your enterprise maybe have been may be affected by some sort of intermittent outage. How do you keep your retail store up and running so you're able to check out your clients? How do you keep your manufacturing site running so that you're able to continue to do your manufacturing processes? How do you keep your industrial site going? Any of these things where continuous operation is really critical to your business, you need to have that compute capacity local to where those processes are being performed. All of those are what we call edge computing. So hopefully that gets us all up to the same level of understanding of what we're talking about. Let's go on and talk a little about some of the use cases that we've experienced. And frankly, the use cases are enormous. We've seen use cases for edge computing in virtually every industry, whether that's agriculture or manufacturing or retail or warehousing or logistics, or you name it. Every industry we've seen the potential utility of edge computing, and really kind of seeing this evidence in the number of edge devices that are now being exploited and produced and put into production environments. It's been, as Jill said earlier, I'm retired now, so I don't have direct access to the information anymore. But as of when I did retire, we saw on the order of 15 billion devices already in market, already being used in production environments. But IDC and Forrester and all the rest, Gartner, et cetera, all of the analysts predict that the growth of edge computing is just going to be mind-boggling. 30, 50, billion devices in the next few years, and you compare that to the number of mobile devices that we have out there already, which is probably on the order of about 3.5 billion, edge computing will eclipse the amount of compute power that we typically see in the mobile space today. But let's just talk about a couple of those. And one of that I like to talk about is retail, because it's kind of near to all of us, whoever we are, whatever we do, we all end up experiencing the retail environment, whether we go to the grocery store or to clothing stores or hardware stores or wherever we go to, we experience the benefit of edge computing in those environments, first and foremost with the point of sale terminals, all of which essentially now are being run as edge computing devices. They have, an ARM or AMD or Intel chip in them. Maybe even some of them are starting to get RISC-V. I don't know, but that was certainly seemed to be a trend for a while. Chips in them. They're running Linux. They're capable of running containers. If they're not already, they're moving in that direction typically. And so all of them sort of qualify as potential edge devices. Store management, whether that's trying to track for spillage and spoilage in a large, grocery store, or trying to identify inventory and the need for replenishment, or other environmental, things like, how do you maintain and manage, the HVAC system so that you have the right temperature in your store to be attractive? How do you monitor foot traffic so you know where people are spending dwell time? What kind of products are they looking at more than others in order to better track what people are interested in? And then, of course, the industry calls it shrinkage. I think most of us will think of it as theft, but trying to keep track of where are people pickpocketing or picking up product and taking it out without paying for it. All those kinds of things become ideal candidates for the use of edge computing. We're also seeing a tremendous transformation of how shelf labels and other digital displays are being employed to automate the process of updating prices. I hate to get into the whole topic of inflation, but of course, if you're a store and you're having to go out there and update your shelf label every few days or a couple of weeks or whatever, to reflect the inflation of your product, that can be a very time-consuming and expensive activity. And so getting to a digital shelf label or getting to a digital display that's more directed at your clients and kept up to date, those are good examples of where edge computing is needed. And all the retail industries are looking to try to transform customer service and how store clerks and colleagues interact with their clients and help them find the products that they're looking for. Another really interesting area to examine is what's going on in the agricultural space, whether this is through better irrigation management to be able to deal with the shrinkage of water supply, or to get better efficiency and utility out of your use of irrigation, trying to manage how you fertilize your crops so that you're getting just the right amount of nutrition into the soil without risking runoff that might be polluting our rivers and lakes and oceans. Likewise with pest control and trying to manage which pesticides to apply when and where. Managing your inventory. And this becomes a really interesting challenge when you think about it from a national protection standpoint, and how do you ensure that you're able to keep track of where food inventory is and how your supply is being managed if you're trying to respond to a point of national crisis, or even if you're just simply trying to manage inventory and supply against local markets. When is the right time to harvest? What are the costs of sending wheat to the dryers and to the storage facilities based on spot pricing, the cost of those activities? Managing equipment and keeping your tractors and other equipment up to date, and being able to address any maintenance issues there. And of course, how do you assign personnel and activities there are all really interesting use cases for edge computing, and bringing that compute local to the farm and to the farmers, and exploiting some of the advances in sensor technology that are available to farmers these days so that they can do a better job managing their environment. So those are just a couple examples, and there's a lot more that we can go into if we had time. But I want to try to kind of shift our topic now to thinking about some of the challenges with edge computing, because like all new architectures, if you're not familiar with not just the technology, but also how best to leverage and utilize that technology, then there's a high risk that we're going to fail to deploy these architectures in a production environment. And so it's important to think about and understand these challenges. But let me just sort of start with application design. What's important here is that we be able to leverage what developers already know. And what they know today is how to build cloud-based application solutions, cloud and web-based applications. So tapping into that skill, tapping into that knowledge, tapping into their understanding of how to build a successful and resilient application is key. And being able to exploit that to bring that to the edge is also important. But there are some differences. And not the least of which, of course, is that when you're dealing with edge computing, you're probably dealing with a more resource-constrained environment. If you're working with, a Intel NUC class machine or a Raspberry Pi or any of these sort of small devices, you have a limit on how much memory and storage, and even whether you have things like GPUs and other processing offload capabilities that may constrain what you are able to do with software running on this device. And so you have to think about, how do you partition the work that you're going to perform at the edge versus what work you need to perform in the cloud, and how do you balance between those two things to be able to get both the latency and the data protection and the resilience and the efficiencies that we talked about earlier, but by the same time accommodate the restrictions you're going to have, and therefore the limitations of what you can do there at the edge. Another key issue here, and especially in today's age when we talk about AI and almost everything anymore, how do you get those models into the edge, and how do you get them to be efficient and compact enough to fit within the resource constraints of the edge computing environment? How do you keep those models up to date? How do you collect training data? How do you get the training performed and put back out to the edge so that you can keep your edge computing systems up to date? Which leads us then to the thought of, how do you keep the applications up to date? How do you place the right software into those edge devices? How do you get the right software to the right place at the right time? And how do you keep it up to date as you continue to improve your software and put up new versions? If you think about, the retail environment, you may have 10 different kinds of devices being used for, perhaps hundreds of different purposes. You may have hundreds of cameras, and if they're smart cameras, each of those cameras may be in a different place within the store with a different purpose, and therefore getting the right software there becomes really important. But also how you keep that up to date is important, and being able to do this at scale, because typically when we're talking about edge computing, we're talking about not just 1 or 2 or 10, maybe not even 100 devices. You may have hundreds of devices in a given store and thousands of stores across your enterprise, or tens or hundreds of warehouses, or tens or hundreds of manufacturing sites with literally thousands of devices, each dedicated to a different purpose. And how you manage that? How do you manage that at scale so that that doesn't become an administrative burden is a critical issue. Be able to do that autonomously and flexibly. In fact, these are kind of some of the issues that led to the demise, if you're familiar with it, of what we called client-server computing back in the 80s, or even service-oriented architecture-based computing in the 90s and the early aughts. Those distributed computing architectures were brilliant in many ways. They were opening up whole new vistas for how enterprises could structure their IT needs, but prior incarnations of this failed because people didn't concentrate on the management problem, the administration of software, how you get that right software out there, and how do you do that at scale and flexibly in the operations of your environment. were what essentially killed those. And the only reason that mobile computing has been able to get by around this is they essentially distributed responsibility of managing the device to the person holding the device. So each of us as end users of our mobile phones or tablets have essentially assumed responsibility for ourselves for managing our own software on those devices, which is fine in sort of the consumer space. Although I'll tell you, my mom doesn't always do a great job of keeping her cell phone up to date, but for the most part, we all kind of handle that okay. But that won't fly in an enterprise environment where workers may or may not be thinking about how to keep their devices up to date. If you've got engineers or manufacturing production people out on the manufacturing line, their focus is on getting their job done, not necessarily keeping the devices up to date. And in many cases, they don't even have to do it. The device doesn't really belong to them. The device belongs to the operations systems on the production line, and it may or may not be their responsibility to keep that software up to date. So you got to think about the automation of these management problems. We're going to talk a little bit more about security here in a minute if I have time. But this is really a critical issue, and one of the things that really have to think about, again, not only is edge computing essential for securing the data and for confidentiality or business protection purposes, but these devices are out there in the open. They're out there, not protected by the traditional four walls of an IT data center or cloud data center. And so you have to think about how you secure and protect those edge devices. We'll talk a little about that later. When it comes to data privacy, of course, what you have to think about is how are you going to encrypt that data? How are you going to filter that data? How are you going to keep that data from propagating to places that other people can intercept them? And of course, you got to think about connectivity. How do you secure that connectivity? How do you make sure that network connectivity is isolated to your enterprise and protected by that? And finally, there are organizational considerations. So edge computing doesn't come for free. You do have to think about these issues in as much as we are leveraging the skills and capabilities of application developers and DevOps teams that largely are building on the skills and knowledge that they built around cloud computing. There are other considerations that have to be factored in to be successful with your edge computing. Which kind of leads us then to this thing that we call Open Horizon, which for many of you, hopefully is a Linux Foundation and LF Edge project. And it's a project that was introduced extensively for the purposes of solving or at least assisting with some of those issues that I've just mentioned. So what is Open Horizon? It is a community-based open source project at the LF Edge within the Linux Foundation. It is designed specifically to enable autonomous management, delivery, deployment, and maintenance of the software that you're going to deploy at the edge, and to be able to do that at scale. It is designed with web scale in mind. It can handle literally tens of thousands of edge devices and manage getting the right software out to each of those devices, even if every one of those devices is different, or in some cases where some of those devices are similar, performing similar tasks, it knows how to deal with that at scale. It has support for a variety of container platforms. And even I didn't emphasize this point enough earlier, I have to say, containers are key to success in both the cloud and in edge computing. Containerizing, service-orienting, compartmentalizing your software is really essential. But that also means that we have to be thinking about what are the container platforms. And as much as we all love Kubernetes, it's also important to know that Kubernetes doesn't necessarily always fit on some of these more resource-constrained devices. And frankly, it's kind of overkill for some of these devices. If you have an intelligent camera, for example, running Kubernetes on camera probably doesn't make a whole lot of sense. It's not necessary. So thinking about how you use Docker or Podman as your container runtime in these kinds of resource-constrained devices is important. And again, Open Horizon supports both Kubernetes, but also Docker and Podman. And it's designed to support disconnected operations. And that means both disconnection of the edge device. If you have a network failure, you want your edge device to continue to operate, but also in the case where you need your management hub to be managed in its own isolated environment. If you need to firewall or put a moat around your operations environment in the production environment, then we can do that as well with the management hub. And it is designed for applications that use AI and ML, and I'll explain a little bit more about what that means in a minute. Just to kind of give you a little bit of insight as to the structure, the architecture of Open Horizon. It begins with a centralized management hub, called the Open Horizon Management Hub, that runs on Kubernetes. Itself, it runs on Kubernetes. And it's made up of 6 main components. And unfortunately, I won't have time to go through all these details right now, but the switchboard is responsible basically for securing and protecting the communication between the management hub and all of the edge devices. The exchange is where we kind of do all of our record keeping of the current state of the system. The agreement bot, or sometimes affectionately called the AgBot, is the one that's responsible for managing the policies that govern the deployment of containerized workloads out to the edge. The model manager is so we can isolate and separate the container, which contains the application logic, from the AI or ML model or other metadata that you might want to isolate from the container. So those can be managed on a separate lifecycle. Open Horizon supports the latest version of the FIDO device onboard, or FDO, for both device attestation as well as zero-touch provisioning. And the secrets manager is also key to be able to protect any information that you need at the edge, where that edge computing is being performed sort of out in an open, unprotected environment. All of those then are supported by an edge node, what we call the Open Horizon agent, which connects back to the management hub and collaborates with the management hub over decisions that allow deployment of containerized workloads out to that edge node. The node agent is a relatively small piece of code. I think as of last count, it was around 30 or 40 megabytes of code, not including the container runtime. And that was enough to be able to both register and manage that node with the management hub, which includes the testing for that, the veracity of that node, as well as managing and negotiating agreements, synchronizing models, as well as monitoring agreement conditions so that if anything changes, it can go back and renegotiate changes, and keeping the local environment, the edge environment, up and running, even if there is a failure to connect back to the management hub for a while. And it does that for every edge node that's out there. There's an edge agent that gets deployed in each edge node and connected back to the centralized management hub, and supporting both devices and clusters, as we talked about before. So how does this help? Open Horizon helps really to produce successful edge projects. It employs what we call policy-based deployment management. Policy-based deployment management is key to be able to manage these things at scale. So you can set your deployment policies, you can condition those with a set of what we call node policies and service policies, as well as model policies. And those things together are how you express your needs for what software to get deployed to in what locations, with a fairly clean separation of concerns between those people that are responsible for the software, the service that's going to get deployed. So you got the software engineer involved expressing service deployment policies, service policies. You have the operations team who have responsibility for the edge infrastructure and getting the right operating system out there and determining the purpose of each of those edge devices. So they have a role and they can specify that through node policies. The DevOps team, or sometimes the CloudOps team, who is involved with deployment processing and their own concerns, which are elevated above the software, the service, but rather really kind of looking at coarser grained issues like, you know, what is the intent at this store versus that store? What are my constraints on where I want the software to be deployed and so forth? And finally, for the data scientist, the model policy. So each of those roles within your organization can express their needs from their perspective and then use that to manage the deployment of the system. The key thing is that this works whether you've got one device or tens of thousands of devices. And this becomes important to think about because it's common that people will start by trying to, wait until they've got tens or hundreds of devices before they start thinking about the management of that stuff. They'll do the one or two devices in sort of a manual way. And then, then they might script the automation for the next 10 or whatever. But the problem with that, of course, is that eventually you have to make a decision about how you manage this thing at scale. And if you haven't started from day one with a management system in mind, then you've got a lot of rework to do. So we really encourage people to think about that. It does separate the container from the AI model. It uses modern software development practices. We talked a little bit about that already. And it is community-based. It is an open source project, but there is commercial backing, and IBM being one of the key commercial backers of this in the form of what we call the IBM Edge Application Manager product, which is really just a commercial distribution of the Open Horizon project. Now, I won't have time to go into all these details, but I do want to kind of highlight at least a few of the security issues that we have that are built into Open Horizon and are essential to protecting your edge environment. And it starts with device attestation, being able to identify the individual devices, be able to resist people tampering with the software while it's being in transit, being able to prevent people from connecting to the edge device and using that connection to tamper with or to intrude in on the device itself. There are no open ports. The edge agent always connects back to the management hub. It never has an open port for people to connect to at the edge, and this helps prevent people from sabotaging the edge device. All messaging is performed with perfect forward encryption, which helps prevent anybody replaying the messages as they're being performed back and forth between the agent and the management hub. Isolation with the workload through containers, blast protection by limiting the capabilities that anyone can do with the identity of that edge device. Introduction of role-based privileges so that we can control who has authority to perform what tasks within the management realm. The secrets manager, which allows secrets to be distributed to the edge software without that software having to hard code the secrets or having to keep those secrets in the clear. The secrets manager will distribute the right secret to the right edge based on the software that's been deployed there. Failure resistance, which means basically the edge agent is able to continue to operate even if connectivity back to the management hub fails, and will resume its role even if the device gets restarted. And then keeping your infrastructure up to date by getting the right software out there at the right time and keeping it up to date really helps protect your environment. It's important to understand about connectivity and the interplay between edge computing and networking and how they're deeply intertwined. Of course, edges need to be connected. They need to be connected securely, reliably, and economically. But in order to create those connections, network connectivity needs the edge to be able to encrypt messages in the message stream. It needs to be reliable. It needs to be economical. And so for all these reasons, network connectivity itself depends on the edge. So we think about the connected edge as being almost a synonymous and integral part of what we think about when we talk about edge computing, which kind of leads to this notion of DevSecOps, which I won't have time to get into, but we do talk about a little bit in the book. So if you're interested in learning more, I encourage you to join the LF Edge Open Horizon project. There's a QR code to get you to the Open Horizon site. I invite you to follow that link and get involved. And as we started with, Sanjeev and I have written a book about Open Horizon. It just got published a couple of weeks ago. And if you're interested in getting a copy of that for you, there is a discount, 20% discount. If you want to go to Amazon and enter this code at checkout, you can get a 20% discount on the book, and that'll be good until the 10th of August. So with that, I went over, forgive me for doing that. I think we want to switch, and we're going to do a little bit of a conversation here. And so let me turn it back to Sunny. Are you there?
Yeah, I'm going to step in here. We had some questions that we wanted to ask. So that was a great presentation and really useful info. Thank you, Rob. Pivoting, can you share some additional real world applications of Open Horizon, and talk a little bit about the impact that those applications have had since being implemented?
Yeah. So as I mentioned, we've seen use cases in both retail and in agriculture, but let me shift over to another area where we see a lot of use of edge computing, and that is manufacturing. I kind of hinted at this even. And a good example is one we did for a manufacturer, it was an automobile manufacturer who, if you can imagine what the manufacturing process is like, there's a lot of welding involved, right? You're welding different body parts together and parts of the frame and so on and so forth. And one of the issues often in that industry is how do you determine the quality of that weld? Now, traditionally, what the auto industry has done is they'll take a body or a frame off of the assembly line, every 10th car or so, and they examine the welds that were performed on that frame. Sometimes that might mean using a X-ray machine. Sometimes that means cutting it open. It's a destructive process where you literally have to cut open the frame and look at the inside of the weld to see how well it's been performed. And of course, that's very expensive. It's expensive to take that off the assembly line, and the disruption that causes is expensive to perform these tests. It's expensive if you do a destructive test and have to re-weld that stuff back together. It's even more expensive if you discover there is a quality problem. If you're only testing every 10th frame, then that means you don't know where the quality issues started, since the last frame you tested. Was that 5 frames ago, 10 frames ago? Who knows? So to adjust that, our global services team went in working with the manufacturer and put infrared cameras on the manufacturing line, and they used a machine learning model, an AI model, to look for the quality of the weld at the moment the weld was being performed. So it's in real time, without having to do any kind of destructive or offline testing. That could tell for every single weld whether that weld was being performed correctly or not. And if there was a quality issue, and I think they identified, I forget the number, but on the order of 120, 140 different quality issues that could occur, they could remediate that almost immediately. So dramatic reduction in cost. Now, of course, if you think about that, you've got 200 robots performing welding activities. Each of them has an infrared camera on it, and each collecting a tremendous amount of video data. If you're going to send all that video data back up to the cloud, that is going to overwhelm your network.
Mm-hmm.
You either have to have a very expensive network in place to be able to support all that data transmission, or you simply are not going to get it all. So by putting edge computing in place, they could process those images locally, make those determinations locally, basically just focus on the one frame that evidenced the quality issue, and throw the rest away unless they wanted to, maintain some, subset of that for training and quality purposes later on. But otherwise, they dramatically reduced their cost by doing that. And so that was just one really interesting edge computing use case that we see.
Yeah, and it sounds like that could be applied to other industries as well, not just the auto manufacturing.
Yeah.
Yeah.
Yeah. I sort of mentioned this, but I think visual recognition, whether it's for quality inspection or foot traffic detection or dwell time or even identity purposes, that's probably the most common exemplar of edge computing use cases these days. But it could also go to acoustic monitoring. It could just go to simple, analog sensor, digital sensor tracking. If you're looking at the vibrations on a bridge, you want to be able to track whether those vibrations represent a risk of failure, for example. All those sorts of things are very common.
Yeah, great. So we shifting gears just a little bit. We did have a question come in through the chat window. Our viewer here is asking how Open Horizon addresses nodes or node management.
Mm-hmm. So there's 2 things to think about here. One is the software, the management software itself. So the agent. How do we get the agent onto the device, and how do we keep the agent up to date? And the second issue is, well, the agent's there to be able to get the software, the application software onto the device. So let me take this in reverse order. The agent interacts with the management hub. And through the policies that I mentioned earlier, the management hub and the agent are going to negotiate over whether a particular piece of software should be placed on that node, the edge node, right? And those policies may have both conditions as well, or have expressions, assertions, as well as conditional expressions. So between the combination of these different policies, they will determine what's the appropriate software to place on each node. Each node is going to do that individually in conjunction with their corresponding management hub. Once that's been determined, an agreement is formed, and the agreement basically is, a contract to deploy a particular piece of software onto a particular edge. That contract then is then monitored by both the agent and the management hub, so that if anything changes, like the software is updated, or the purpose of the edge node changes, or its capabilities, somebody may go do a field update to the edge node to either increase the amount of storage it has, or perhaps install a GPU, or change its location, any of those kinds of things that can be done at the field. If those changes violate the original conditions of that agreement, then that agreement is basically invalidated. The workloads are terminated, and a new agreement is automatically negotiated. So that may result in a new set of software being put on that device. It may be result in an upgrade to that software being placed on that device. And so all that's handled automatically. That's the role of the management hub and the agent in the agreement processing. Now, the agent itself is also subject to change and be updated. And there's a corresponding management, we'll call administrator policy, that acts in very much the same way, that negotiates over updates to the agents, and will determine which agents need to be updated when, under what conditions, et cetera, et cetera, et cetera, et cetera. And so all of that's just fully automated. Now, of course, to be able to do that, you need to have the agent on that device to begin with, and that's where FDOs comes in. The FIDO device on board is there to help automate the process through a zero-touch provisioning system of getting the agents onto each of those edge devices. And by the way, in doing so, proving that that device is what it claims to be, that it's a legitimate part of your portfolio and inventory of edge devices, and not some rogue device that has inserted itself into your network. It can determine all of that to make sure that that rogue devices are not being inserted into your enterprise.
Great. That was a really great answer. Thank you. So shifting gears a little bit, I know we talked about some real world examples of use cases and deployments. Are there any other use cases kind of on the horizon that maybe we haven't really seen in production yet that we're expecting, maybe from some different industries?
Yeah, so one that's getting a lot of attention right now is the green shipping industry. For anybody who has been monitoring all of our global climate change issues, there's a lot of focus right now on transportation and how it consumes a tremendous amount of energy, but also produces a lot of greenhouse gases. Shipping being one of those that is particularly egregious. And so there's a lot of interest right now from the shipping industry on how to improve the carbon footprint of the shipping ships. One way to do that is with having a digital twin that represents the current ship operations. And by that, I mean, not only the engine's performance and how it's, consuming fuel and how many emissions it's producing, but also just how the whole ship is being operated, how it's being navigated, what kinds of systems are being left on that don't need to be on or not being brought up when they need to, how to manage waste from, the ship being produced in its operations and so forth. There's a whole bunch of these kinds of issues, and by having a digital twin, then the ship operators can actually begin to monitor ship operations better and look for ways of improving the efficiency of that transportation. So digital twin for green shipping is a major area of interest. There's a major initiative going on in the European Union around trying to invest in these improvements. And so that's one example. And a sister piece of that is actually in the ports themselves. And how do you increase the operational efficiency of the port, getting ships in and out, getting the cargo loaded and unloaded, getting it transported after that, so that you can turn these ships around. They're not sitting out there in the harbor idle, just wasting a lot of energy. Sanjeev, did you have any others that you want to throw in there?
So, as we had discussed earlier, there are several different use cases and verticals that can go into. And agriculture, we are seeing a lot of reception of this technology in agriculture field. And as Rob alluded to, we have some European partners, and not just the industries, but at the level of different government level as well, where they are paying big attention that how we can manage some of these things, how we compensate farmers, how we increase their productivity, privacy, all of those concerns. And also industrial segments across the board. And we have seen a lot of traction in defense as well. So I don't want to go into too much details, but question is that as compute becomes much more pervasive all around and becomes cheaper, starting to find a lot of use cases along those axes.
Mm-hmm.
Yeah, we actually just published a use case with the Fledge project in collaboration with LF Energy. You've probably seen it about reducing some carbon footprint and from a French transmission organization. So we'll go ahead and put that in the chat window. But yeah, I think that's kind of what we're seeing across the project, not just with Open Horizon, but a lot of more energy, industrial, some maybe different verticals than we would traditionally think of, like with telco or just basic network connections. All of these organizations, all of these industries use networks to transmit information, so it seems like those are good opportunities for edge computing. So with that in mind, what are some benefits for people to get involved in LF Edge as a whole? And what are some ways to get started, both either as an organization or a contributor?
Yeah, so I included in the deck a link to the Open Horizon project, but the LF Edge is really a composite of several projects, and all of them have a dedication to edge computing in some way or the other. And the benefits are, I think hopefully obvious, but let's just state the obvious, which is, if you get involved, you get close to the code. You get to know what these technologies do in a firsthand way. You get to participate in their evolution and shape the direction they're heading in. You get to get deep into their veracity, meaning, how do you know that these things are secure, they're well engineered? You get to take control in some sense of ensuring that the software that you might want to leverage has the properties and characteristics in it that you need and that will benefit your enterprise organization. And of course, it's open source, right? Which means that, if you are standalone, if you're self-sufficient in being able to maintain your code, then this gives you access to that code, quote, for free, and allows you to assume the burden and responsibility for maintaining it. And as I said earlier, but there are commercial entities in many of these cases that will stand behind that code and perform maintenance and management for you, and will, in some cases, enhance the code in slight ways. So, for example, I talked about the IBM Edge Application Manager. Two of the key things that it does, the IBM does above and beyond the Open Horizon open source code, is it has a GUI. It has a UI-based interface. It adds that. So everything that you can do with Open Horizon through the CLI and APIs, it gives your operators the opportunity to use a UI in those cases where that's beneficial to them. And there's a lot of hardening activity that goes into running that onto OpenShift as a Kubernetes platform and making that available both in the cloud as well as in enterprise data centers, in the hybrid cloud or the multi-cloud environments.
If I can add further on this, though the commercial offering available, if somebody wants to practice and learn about this, though we mentioned Kubernetes-based management hub deployment, it is also possible to run Open Horizon, what we call all-in-one. So there's a management hub component and then the agent that kind of we talked about earlier. You can run it just as a simple Docker compose, people who are familiar on the call about technology, that you can run the whole all-in-one management hub locally on one machine and then start deploying agent on your edge nodes. And this is 100% very similar to what it would have been in a Kubernetes-based deployment management hub. So you can start practicing today, and all of the links in our Open Horizon link that has been shared has the details about how to go about it. In fact, in the book, purposely, we started with actually IEM, what we call IEM Management Application Manager in mind, but we pivoted to a large extent to use Open Horizon itself, the open source component, and develop the whole deployment and example applications right up to building a real world Agile application that can give you the full end-to-end view of how you can start getting some experience, and how you can start building a real world examples, applications actually.
Yeah, really good point, Sanjeev. Yeah.
Yeah, so we just had another question come in. Nitin is asking how Open Horizon approaches observability.
Yeah, so observability is, I'll say, partially covered in Horizon, Open Horizon. So first of all, I've talked about the agreements that get formed. Those agreements are things that you can collect and monitor. In fact, some people use that as sort of this running, non-reputable audit of the decisions that the system made, so that you always know exactly what decisions were made and why they were made, what conditions were satisfied when they were made. If you ever need to go back and make sure that your system's operating the way it should be, or if you have a need to see what went wrong if something did. Also, the exchange in the management hub has APIs to all the data that it collects. As I said, the exchange in the management hub is really kind of the where we do all the history and state collection for the system. So all that data comes in and is managed through the exchange, and through the exchange APIs, you can query against the current state and against the historical data that is collected. The Open Horizon team, I say we here by extension, but it's the Open Horizon team sort of made some very deliberate decisions about maintaining separation from the application. So while the management hub is, and the agent is responsible for getting the application software to the right place at the right time, we didn't want to interfere with the ability for the application to perform the functionality that it needs to perform at the edge in collaboration with the cloud or IT data center. So we don't intercept any of the communication between the edge application and the centralized cloud or data center application. We don't force any of that communication to go through the same network that the management hub and agent use to communicate with each other. And part of that was to sort of stay out of the way. So we're not limiting the innovation that application developers may introduce into the application. But also a big part of that was because, frankly, those are application concerns. And we didn't want to assume anything about the application. So we don't observe the application other than the fact that it got deployed and the reasons for why it got deployed, and then any changes that might occur that result in that application getting redeployed or a different application getting deployed there.
Okay, great. Thank you. Another question just came in, wondering about the difference between Fledge and Open Horizon. That's actually is a really good question. I know there's confusion among some of our projects and which ones manage what type of activities.
Yeah, so I don't want to get into the weeds on this. I mean, it's probably best for the Fledge team to have a presentation on what they're focusing on. But the way I think of those distinctions is Fledge has a broader concern about the edge device itself, within which one of the concerns is how do you get the right software on there, which is the role of Open Horizon. And Fledge actually has capabilities for incorporating different management systems, software deployment systems, Open Horizon being one of the key ones. But that's kind of the way that I think of it. It's sort of an inverted T, where Open Horizon is narrowly focused on the problem of deployment and getting the right software to the right place at the right time. And Fledge is a little bit more of a infrastructure and operations management layer, that platform underneath that.
Okay, great.
Sanjeev, did you have any other qualification on that you want to throw in?
No, I think that's perfectly all right.
Okay.
Yeah, and you can check out the if you go to the projects page on the LF Edge site. If you go to Fledge, select Fledge, and there's going to be a little more information and detail about what they cover specifically. But great question. Thanks for asking. So we just have a few more minutes left, a couple more questions. If somebody wants to get involved, well, we talked about getting involved in LF Edge, but do you have any advice for people new to open source, new to the LF Edge community, and how they can be successful?
Yeah, I mean, so get involved is kind of a loaded way of saying it, but nonetheless, what we mean here is, everybody always sort of wonders, well, I'm new to this. How do I first get involved? What's the first thing I should do to get involved? Well, just go to the site to begin with and sign up for the newsletters or the distribution lists or whatever. So you're starting to get information coming in. All these things are based on GitHub. So obviously you need to have a GitHub ID that you can use. And, if you want to get deeper engaged, start with the documentation. Do you see bugs or problems with the documentation? Start reporting on those. If you get deeper into the code and begin to see problems in the code that perhaps nobody else has recognized, you can begin to submit tickets on those issues that you identify. And in that process, you get your name known a little bit and get more familiar with the community and how it operates and how it responds to that sort of stuff. Next step is to start debugging, right? Fix the code, right? The whole point of an open community is to contribute in some way, some meaningful way back to the community. And the best way of doing that starts with fixing the bugs in the software, because that's one of the advantages of having open source is you get lots of eyes on this code. Finally, as you really start to get deeply involved with the community, there is a governance process for submitting change requests and for getting those change requests elevated to a priority and actually contributing updates to the code, whether that's new features or functionality or whatever. So you can progress your way into it, but it starts with just sign up to get into the community and start monitoring it.
Yeah, that's a great way to just really get to know and understand what's going on at the technical level and, kind of build out your expertise from there.
I would just add that, yes, exactly. Start playing with, fork the code, start playing with it. And I will definitely plug this, that Joe Pearson, I think he's also on the call here. The team is a wonderful team. They're very receptive of new members. So once you have ideas, suggestions, start from documentation to code, features, functionality, very receptive. We have very regular meetings throughout month with a couple of different meetings. We have separate components for management hub, agent, all of these pieces. So yeah, welcome and join the team.
Yeah. And in addition to Joe, who I agree would be a prime person to go connect with, also reach out to John Welke.
John Welke
actually used to work in the IBM Edge Application Manager, but has recently, in the last couple of years, joined LF Edge, and in fact is leading a lot of the cross-project discussions that go on there, and he's a outstanding resource to connect with too at LF Edge.
And actually, I see a lot of members of the development team is also on this call today.
Yeah.
So that's
Doug,
all of these guys are great.
Lily, yeah.
I see Doug. I see. Yeah.
All right, so just to close things out today, can you give us just a really quick high-level note on what's next for Open Horizon? What can we expect to see?
Well, actually, Sanjeev, why don't you take that?
We have come to a point where it is pretty matured in a way that it can do what we want to do with it. We are starting to look into integrating this project into a couple of other high-value capabilities. And in fact, we will see that it's starting to be used in a couple of other internal projects. And we will be enlarging the scope of managing the AI models. Right now, it was focused on device, but recently we released for edge clusters as well. So some of those are trajectories that we are working on currently. And again, there is a list of items if you want to do that, and that's there on the Open Horizon website. That's in the plans. Anything else, Rob?
No, I think you hit it. I mean, I think that the biggest thing that I would be looking for from Open Horizon is the opportunity. There's opportunities for it to get embedded within various industry platforms. And the one that really kind of, strikes me as being primed for this capability right now is the automotive industry and how it's transforming, all of our vehicles to be more software based than hardware based. All the vehicle manufacturers are re-architecting their vehicles to centralize compute capacity in their vehicles. But, Tesla, I think, has really kind of demonstrated what it means to do open over-the-air updates on a frequent basis and be able to manage, deployment of changes and new functionality and fix bugs and all this sort of stuff that go into the car to make the car, feature rich. All of that is, I think, a prime candidate for exploiting Open Horizon and, frankly, other LF Edge projects as well, but specifically around over-the-air updates.
Great. Sounds like there's a lot of really cool things to look forward to. And on that note, we did get one last question. We have somebody wanting to know how frequently we can see models getting updated, especially with data and AI analytics coming through.
Right. So I'll take that one. Essentially, again, I just said, Open Horizon manages the control plane and doesn't get into the data plane as well at all. So the question here is this particular model is up to the application designer, because all the inferencing, what we advocate, that it should be done on the edge where data is generated. So it's up to the device capability, whether it's GPU based or just CPU based. You can do inferencing right at the edge, and you can get the result as soon as it can process it. And I have seen that it could be a real time, 30 frames per second or 60 frames per second. You can do all of that based on capability of hardware currently available in the market from NVIDIA and other GPU manufacturers. So it's up to the application design that what kind of ML model you're using, either YOLO or TensorFlow, PyTorch, whatever, and how do you keep the size of the model small? How do you design your application? But we will manage, when I say we, I mean Open Horizon will manage the deployment of your containers, deployment of your application AI models, and it's up to the application designer to leverage that to create the inferencing as fast as they can.
Yeah, a couple of things I'll add to that. One is when a new model is deployed, the application can immediately begin to use it as soon as it arrives without having to restart the application. So this is a key reason for separating the container from the AI ML model, so that those updates can occur without, quote, disruption. You don't have to restart the application before take advantage of that new model that arrives. But after that, the only thing that's constraining the frequency of those updates is transmission cost or transmission time. So if you're doing your training in the cloud, which is fairly typical, and then transmitting that down through Open Horizon to the edge, there's going to be a cost to transmitting that ML model to the edge. And then there's a little bit of overhead in, managing the policies around deciding what models to deploy where. So there's a little bit of overhead there, but that's really the only big constraint in the frequency with which you can deploy those models. Now, of course, there's going to be latency in the training process itself. So if you're collecting data from the edge and bringing it back and training it in the cloud, and that takes you cycles to do that training, then that's got to be added in, but that's out of our control. That's really kind of, as Sanjeev said, your application design. And, key to that is keeping your models small. Keep your models as narrowly focused on the thing that you need them to do as possible.
Yeah, purposely we kept in Open Horizon the containers, and what we advocate is that an AI model lifecycle separate. So you can update your container code as fast as you want, or ML code as well, models as frequently as you want. And it's up to the, it will be obviously serially delivered to the edge nodes, and all that is managed for you by Open Horizon.
Okay.
Joe, if I could real fast, just
yeah.
say to John and Lily and Joe, and who else did I see on here? Doug, guys, I'm sorry. I see you on the thing. I can't chat on the thing, but I just want to let you guys know that I see you guys and miss y'all. But thank you guys for joining, and thank you, Joe, for hosting us, and thank you, Sanjeev, for all your support here.
Thank you. You're welcome. It has been a pleasure. Yeah.
All right. Well, thank you, everyone, for joining us. Thank you, Rob and Sanjeev. This was a great discussion. We'll continue to embrace open source and watch what happens with Open Horizon and the rest of the edge space. Again, this recording will be available to watch on demand, and check out Rob and Sanjeev's book. And we'll talk to you all later on another webinar. Have a great day.
Thanks a lot, Jill.
Bye now.